Hi, my name is Juan Rodriguez and I'm a student from the Universidad Rey Juan Carlos at Madrid, and this is a presentation of Airborne Traffic Situational Awareness, ATSAW. As air traffic is predicted to increase steadily over the coming years, there's a clear need to ensure that standards of safety and efficiency are maintained or even enhanced. This is recognized by the Single European Sky program in Europe called CESAR and the Next Gen program in the USA. These are the two major bodies driving the air traffic management development over the coming years. Automatic Dependent Surveillance Broadcast, ADSB, is all about communications between aircraft and also between aircraft and ground. Both are vital in ensuring safe flights and efficiency in terms of fuel use, time, and emissions. ADSB is an integral part of the planned efficiency drive towards 2020. Taking advantage of the latest technology, ATSB is designed to retrofit on aircraft flying today. Here, we will look at aspects associated with the retrofit and take a look at the developments that are planned for the future. ATSB is a surveillance technique that relies on aircraft or airport vehicles broadcasting their identity, position, and other information derived from onboard systems such as GNSS. This signal can be captured for surveillance purposes on the ground in case of the ADSB out, or on board other aircrafts in case of the ADSB in. The ADSB system works in the following way. The aircraft get their position from the GNSS constellation. Then they simultaneously broadcast their position and other data to any aircraft or ground station equipped to receive it. Ground stations then transmit the aircraft's position to air traffic control. Using the ADSB in service, ATSAW is introduced. What is ATSAW? Airborne Traffic Situation Awareness, ATSAW, is an airborne traffic situation awareness system being introduced in commercial aviation, providing pilots with a real-time picture of the surrounding traffic during all phases of flight. Procedures using ATSAW will give the crew the ability to move to more efficient altitudes when operating outside ground surveillance coverage. ATSAW gets the ADSB signals and displays it in the cockpit of the airplane. ATSAW will support visual separation on approach and provide traffic situational awareness on the airport surface. When ATSAW is activated, and if the ADSB information is available from aircraft in the vicinity, the following information is available for each pilot: aircraft identification, absolute bearing, 2D distance, heading, tracking, wake vortex category, relative altitude, absolute altitude, ground speed, and vertical velocity. Here we can see a picture of the cockpit of an airplane that has fully integrated the ATSAW. With the traffic selector switch, the pilot can select the airplane he wants, and we will see later what the MCDU is. ATSAW is split into steps. Step 2A, ATSAW operation in flight, and Step 2B, ATSAW operation on ground. Step 2A, ATSAW operation in flight. ATSAW improves cooperation with ATC. It means that it gets a better understanding of ATC instructions. It improves the detection of opportunities for flight level changes in standard separation, for reduces fuel savings and a reduction of CO2 emissions. It improves efficiency on approach. We will take a closer look on this. It enhances identification and information of target aircraft. It helps the flight crew to acquire and then to maintain visual contact with the preceding aircraft. It enables to maintain as long as possible visual separation. It enables to safely perform approach procedures without visual separation from the preceding aircraft on a more regular basis, and increases runway capacity. Here we can see the pilot can see if there is an opportunity to climb to a superior flight level in order to gain efficiency. ATSAW with ITP, which means in-trail procedures. First we will see what ITP is. ITP is a specific ATSAW procedure for flight level change defined in the EUROCAE RTCA document AD 159 DO 312. IDP defines to reduce longitudinal separation during the flight level change, down to 15 nautical miles. IDP is only certified in the North Atlantic. The ATSAW with ITP enables more frequent altitude changes by temporarily reducing standard separation, enables flying at the optimum flight level, and provides significant fuel savings. In this example, the MCDU, which is the Multipurpose Control and Display Unit, shows the identity and the relative horizontal position of the three aircraft. The pilot can see immediately that a flight level change to FL 370 is not possible until 1412 set time, as computed by the TCAS, Traffic Alert and Collision Avoidance System. A different flight level can be requested as clearly indicated, taking into account the surrounding aircraft position, trajectories, and speeds. Step 2B. ATSAW on the ground. The objective is to improve the safety on airport surface by displaying aircraft and vehicle positional information on runways and taxiways. It can be applied on runways, taxiways, and in all weather conditions, day and night. It enhances situational awareness during surface operations. There's a further step, which objective is to enable the flight crew to achieve and maintain automatically a given spacing with designated aircraft. The two principal maneuvers are remain behind and merge behind. The operational benefit will be the enhanced traffic regularity during the approach to airports with heavy traffic, allowing increased airport capacity. As a conclusion, we can see here a summary of all the benefits that ATSAW provides. First, in efficiency, in the phase in flight, ATSAW provides fuel saving, flight time optimization, increased runway throughput, reduction of radio call and NOx, decrease of missed approaches. And on the second step, ATSAW on ground, it improves taxi operations, airport capacity, departure clearance at the right time, gate occupancy awareness. And in terms of safety, it provides awareness of traffic situations, enhanced identification of target aircraft, readiness of avoidance actions, correlation of radio communication and traffic displays, and on ground, the runway and taxiway occupancy awareness and collision risk anticipation. ATSAW helps gaining experience and confidence for future applications.